Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 1 variant theory. In today's lesson, our main focus will be on mechanics question and also we will discuss some wave questions. As always we will discuss these questions in detail so you can improve your conceptual understanding of mechanics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 7 says, a device for spraying paint consists of a box with its faces horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meters per second through 400 holes, each of area 0.4 millimeter squares. The density of the paint is 900 kg per cubic meter. What is the horizontal force required to hold the device stationary as it ejects the paint? So first of all, let's try to understand what is happening in this case. So in this case, paint is coming out of the box. As paint is coming out of the box, it means there is force on the paint, and that force on the paint is from the box. So there is action force on the paint, so there will be reaction force on the box. So action and reaction forces, these are equal in magnitude but opposite in direction. And also we need to understand, in this case momentum of the paint is changing, so it means there is resultant force on the paint. So we can start with F net with resultant force. So we can write down F net. This one will be equal to change in momentum of the paint divided by time taken. So in this case, if you wanna draw the arrows, so in this case paint is coming out, so this is the action force on the paint, and also there will be reaction force on the box, and these two forces are equal in magnitude but opposite in direction. So change in momentum we can write down, this will be delta mv, mean the change in momentum, divided by delta t. In this case speed is constant, so we can take this is speed, this is constant, and here we have this is delta m over delta t. Now delta m over delta t, so how we can calculate delta m? Delta m will be equal to density of the paint times the change in volume of the paint divided by delta t. Now how we can calculate the volume of the paint? Volume of the paint, simply you can imagine in 1 second how much distance is traveled by the paint in 1 second. As we have the speed that is 2.5 meters per second, it means in 1 second the distance traveled by the paint, that is equal to 2.5 meters. So simply we can draw one cylinder, so this is cylinder. In 1 second the distance traveled will be equal to 2.5 meters. So this is the length of the paint. So we can imagine each hole like a cylinder, and the paint coming out of that in 1 second is like a cylinder with length 2.5 meters and cross-sectional area is 0.4 millimeter square. Mean this much volume of the paint will come out of the box in 1 second. So we can write on delta V in this case. This will be equal to 2.5 times 0.4 millimeter square. So this is 0.4 millimeter square, mean this is 10 to minus 6, because 1 millimeter, this is equal to 10 to minus 3 meters, and 1 millimeter square, this will be equal to square here. So we will get this is 10 to minus 6 meter square. So we can replace with that. But this is not the total volume. The total volume has to be multiplied by 4, because this is for a single hole. So we can say delta V total. This has to be multiplied by 400 times delta V, mean this value. Now we can replace and we can find the answer. So this is the main concept you need to understand. So in this case we have the V speed is given, that is equal to 2.5, and the density is given to us, that is 900, and we have delta V, that is 2.5 times 0.4 times 10 to minus 6 multiplied by 400, because we have 400 holes, and the time taken is 1 second. So this is 1 second. If you solve this one, you will come up with 0.90 Newton. So this much is the force applied on the paint by the box, and the same force will be applied on the box. So to stop this box, we have to apply this much force in the opposite direction of the force on the box. So we have to push this one in direction of paint coming out. So this is how we can balance. So the answer for this question is B. And this question is a repeated question. If you check October, November 2020, paper 1 theory, you can also find this question in that paper. Question 8 says each diagram illustrates a pair of forces of equal magnitude. Which diagram gives an example of a pair of forces that is described by Newton's third law of motion, mean action and reaction forces? For Newton's third law pair forces, we need to understand few points. Newton's third law pair forces. Newton's third law pair forces. So few points we need to understand. First of all, two forces must have equal magnitude. Two forces must have equal magnitude. Then the second thing, opposite direction. So these are common points, equal magnitude and opposite directions. And also two forces should be of same type. So this is very important one. They must be same type of forces, and also acting on two different objects. So acting on two different objects. So this is also very important point. Acting on two different objects. So if you look at these given forces, we will focus on this part, because all of these forces, they are equal in magnitude and opposite in direction. So we will not consider first 2 points, same type. So if you look at option A, this is the driving force and this is the resistive force. So they are not same type of forces. And if you look at part C, they are acting on two different objects. They have equal magnitude and opposite direction. But these two forces, they are not same type of forces. This is the pushing force and this is gravitational force, not same type. Lift is one type of forces and weight is another type of forces. So these are not same type of forces. But if you look at over this system, Earth and Moon system, the force on Earth, this is gravitational force. Force on the Moon is also gravitational force. These two forces are acting on two different objects. They have the same magnitude and they have opposite directions. And this fulfill all these characteristics of Newton's third law pair forces. So the answer for this question is B. A beautiful question, and also this is a repeated question. You can also find this question in other papers. So this is another repeated question. So you need to understand characteristics of Newton third law pair forces. Question 9 says two balls of identical shape and size but different masses are falling through the same liquid. The sum of the drag force and upthrust acting on each ball is equal to its weight. So first of all, we can imagine. This is the best way to answer any question in physics. Imagine means you can sketch the diagram. So we can imagine we have liquid in this container and these two balls are falling in this liquid. So we can draw two balls. We can imagine one ball is here. So this is our one ball and we can draw another ball here. They have the same size and shape. So they have the same size and they also have the same shape. Now we can say, let's say the mass of this one is m1 and let's say the mass of the second one, mass of this one is m2. So this is mass m1, and in this case m2 is greater than m1 because the mass is not the same. So it means that the weight of w2, this will be greater than w1. Now we need to consider upthrust on these two balls. Upthrust depends on the size of the ball and density of the liquid. Density of the liquid is the same, so it means upthrust in this case is the same on these two balls because they have the same size. Same size means same volume. So we can write on here because they have the same volume, so upthrust on these two balls is the same. And in this case, it is given to us the forces acting on the ball. So first of all, we can draw for red ball. So this is for the red ball. The force acting on red ball in downward direction, this one will be W1. And the force acting in upward direction, this one will be upthrust, and there will be drag force. So this one is the Ft. So W1 in this case has to be equal to U plus Ft. But we also need to understand that Ft, drag force, this is 6 pi eta RV. You don't need to remember the formula, but you need to simply understand that drag force depends on the speed. So this is the point you need to understand. Now for the second ball, for this blue ball, we can also draw the weight of this one is greater, so this arrow has to be longer, so weight is greater, so this is W2. So in this case, same amount of upthrust, so this is the upthrust, and drag force has to be greater, so this is the drag force, Fd. So in this case, it is very clear. If I say this is 1, this is 2, so I hope you can simply say now that Fd2, this one has to be greater than Fd1. As Fd2 is greater, it means that the speed of the second ball, it has to be greater than the speed of the first ball. So this is how you can approach this problem. It means that this ball is falling at higher terminal speed, so we can say this one has higher terminal speed because forces are balanced, so it has higher Vt, and this one has lower Vt. A beautiful way to answer this question, and if you understand this question, a lot of question about fluid you can answer. Almost every year there is a one question based on this concept, so try to master this concept. So what is the answer for this question? The heavy ball has larger acceleration? No, because they are falling at constant speed, forces are balanced, so it means this one is incorrect. Has smaller? No, incorrect. They have zero acceleration because they are falling at constant terminal speed, constant speed. Heavy ball is falling at the same speed? No, heavier ball has higher speed. So the answer for this question is T, higher speed, larger speed. A beautiful way to answer. So try to master this. If you understand this question well, it means a lot of question about fluid, about terminal speed you can answer. Question 10 says a perfectly elastic collision occurs between two objects x and y. The mass of x is m and the mass of y is 4m. Object x travels at speed v before the collision and speed 3v by 5 in the opposite direction after the collision. Object y is stationary before the collision. For this question, we need to find out what is the kinetic energy of y after the collision. So first of all, we can label. We can label this one as u1. So this is initial velocity of x, and the initial velocity of y, this is u2, and u2 is equal to 0. And velocity of x after collision, this we can label v1, and for y we can label this is v2. This is perfectly elastic collision, so it means that relative speed of approach, this has to be equal to relative speed of separation. This formula is based on all the objects before collision and after collision, they're moving in the same direction. So in this case, we are assuming to the right is positive, and also you have to take to the right is positive, and all the objects are moving in the same direction. If the objects are not moving in the same direction, you have to consider sign, means direction you have to consider, as in this case we will do. u1 is moving to the right, so this is positive. u2 is 0, so this is simply 0, so we can write down this one is equal to 0. And v2, this is v2, and we have negative sign here, and this is moving to the left, but we have taken to the right positive, so it means this one is negative 3v by 5. So if we simplify this one, we will get v, this will be equal to v2 plus 3v by 5. Now if we further simplify, we can get v2, this will be equal to v minus 3v by 5. So if we simplify, we will get LCM is 5, so here we will get 5v minus 3v. So the final answer for v, this will be 2v by 5. So this is the value of v2. So we have found value of v2. But for this question we need to calculate kinetic energy of y. So kinetic energy of y will be equal to the mass of y times the speed of y square. So we have 1/2 and the mass is 4m, and Vy is equal to V2. So this is over Vy after collision. And the value of this one is 2V by 5 square. Now we just need to simplify. So here we have this is 1 by 2, and here we have this is 4, and here we have m. So if you simplify this one, you will get 4v square divided by 25. Now if we simplify this one, we can take, here we have 4 multiplied 16, we will have 16 mv square. 25 times 2 is 50. So this is the kinetic energy. So this is kinetic energy of y. So this is our final answer. You don't need to simplify. If you look at given option, you see the 50. So you need no need to divide by 2. So the answer for this question is C, and this is how you can answer. A very good technique when it is perfectly elastic collision. Simply you can use this formula, and if the objects are moving in the opposite direction, means moving to the left, you can take that speed as negative, mean that velocity as negative, and always you can use this formula, always, for perfectly elastic collision. What you need to do is simply you need to change the sign if object is moving to the left. If moving to the right, you have to take positive. Moving to the left, negative, because this formula is based on all the objects are moving to the right. So that's the reason you can use this one in this form. But if object is moving to the left, that velocity you will take as negative. Question 11 says, what is not a requirement for two forces to act as a couple? So first of all, let's try to understand what is a couple. So we can imagine a rod, and we can imagine two forces acting on the rod. One force is acting vertically upwards, so this is force F. Another force is acting on this rod vertically downwards. So they will form a couple if they have the same magnitude. So these two forces, they will form a couple if they have the same magnitude. If they have the same magnitude and they have opposite directions, so we can say these two forces, they will form a couple if they have the same magnitude and they have opposite directions, and there is separation between them, separation between lines of action of forces, lines of action of forces. Means, so this is line of action of this force, and this is line of action of this force. So there is separation between them. Simply we can say they are not acting along the same line. If this is true, then this couple will only cause rotation. So the couple will only cause rotation, means the net moment will not be equal to 0. So net moment not equal to 0. But this couple will not cause linear motion. So we will say linear motion. This couple will not cause linear motion. So we can simply cross this one, or we can say no linear motion, because F net in this case is equal to 0. So these are the points you need to understand about couple. So if these conditions are met, these two forces, they will form a couple. So if you look at given options, it is given to us two forces act in opposite directions. This is true. The forces act through the same point. No, they do not act through the same point, because they are separated. So they are not acting along the same line of action. This is asking us not a requirement. So it means this one is our answer. The two forces combine to produce zero resultant force. Yes. So this is right. The two forces have equal magnitude. Yes. So the answer for this question is B. Beautiful question. So these are the points you need to understand about torque of a couple, or we can say when two forces, they form a couple. Question 12 says, a uniform meter rule is pivoted at 34.0 centimeters mark as shown in the figure. The rule balances when a 64 gram mass is hung from the 4.0 centimeters mark. What is the mass of the meter rule? And our answer has to be in grams. So simply for this question, we need to understand first of all forces acting on the meter rule. So in this case, we have weight that is acting at this point, so this is acting vertically downwards, and there is tension in the string that is pulling this meter rule in upward direction. We can say here is tension, and the weight of the meter rule is acting vertically downwards. So the weight of the meter rule, this is equal to mg. We need to find out value of m. So in this case, if we take our pivot at this point, so the moment due to this moment will be counterclockwise, and this one has to be equal to the moment due to the weight of the meter rule, and this moment is clockwise. So simply we can say in this case clockwise moment, this has to be equal to counterclockwise moment, and clockwise moment due to this clockwise moment, this is equal to m times g. This is the g, mass is in grams, multiply by its distance from the pivot, that is 16 centimeters, and this one has to be equal to 64 g. So this has to be 64 g multiplied by the distance. So this is 34, this is 4, so it means this is 30.0 centimeters. 30.0 centimeters. Now from here we can cancel this g with this g. Our answer will be in grams because the mass is given in grams. Then this centimeter, this will be cancelled with this centimeter, and our final answer will be in grams. So we have m, that is equal to 64 times 30 divided by 16. So if we solve this one, our final answer in this case has to be equal to 120, because 16, if we divide 64 by 16, we will get 4, and if we multiply, we will get 120, and the mass has to be in grams because the unit we're using for this mass, that is grams. So the answer for this question is 120. So the answer for this question is C. Question 13 says a volume of 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. The density of water is 1000 kgs per cubic meter, and density of alcohol is 800 kgs per cubic meter. Per meter cube you can say, or you can say per cubic meter. The volume of the mixture is 2.0 cubic meters, and what is the density of the mixture? So in this case we need to understand what is conserved, what will remain same, and that is mass of the mixture. Means the mass of the mixture, this one has to be equal to mass of water, means the mass, total mass has to be equal to mass of water plus mass of alcohol. So we can say mass of alcohol. So this is the main thing you need to understand, what is conserved. Mass of alcohol. Mass of mixture we can write down in terms of density and volume, because we need to calculate density of the mixture. We can say density of the mixture times volume of the mixture. So this is a beautiful way how you need to approach. So volume of the water will be equal to the density of water times the volume of the water. So the mass of the water will be equal to this one, volume of water, plus density of alcohol, so I will be using IL, and times the volume of alcohol. So we need to find the density of the mixture. So we can rearrange, we can write down density of the mixture. This will be equal to density of water, volume of water, plus density of alcohol times volume of alcohol divided by volume of mixture. And so now simply we need to plug in values. So we will just plug in values here. So density of water we have, that is equal to 1000 kgs per cubic meter, and volume of water we have 1.5 meter cube, plus we have density of alcohol, that is 800, times we have its volume, that is 0.5 meter cube, divided by volume of mixture, that is 2.0. Now if we solve this one, we will get density of mixture, that will be equal to 950 kgs per meter cube. So the answer for this question is D. So this is how you can approach questions about mixture. Always you can start with this one, because this quantity is conserved for the mixture. Question 14 says an object is falling at a constant speed through a viscous liquid. F sub u is the upthrust on the object due to the liquid, and WL is the weight of the liquid displaced by the object, and W sub O is the weight of the object. So this is weight of the object. object is falling at constant speed. We need to find out which equation must be correct. So in this case, you need to understand F sub u, this one is the upthrust. So this one is the upthrust, and upthrust has to be equal to the weight of fluid displaced. So it has to be equal to weight of fluid displaced, means weight of liquid displaced. Weight of liquid displaced. And in this case, it is given to us that the weight of liquid displaced, this is equal to W times L. W times L, and W sub O means W naught is the weight of the object. So if you look at given options, in this case, if you look at option A, it is given to us Fu is equal to WL. It means this option is correct. And upthrust, it is given to us, it is equal to WO minus WL. So this is wrong because this is the upthrust, and these quantities are the same. So this is incorrect. Upthrust is equal to weight of the object? No, because there is also viscous drag. So if we draw the free body diagram, so in this case we have downward force that is equal to weight of the object, then there will be upthrust on this object that is equal to F sub u, and there will be drag force on the object that we can say this is Ft. So this is also incorrect, because W sub naught is not equal to Fu, and this is also incorrect. So the answer for this one is A. So simply little bit tricky question, so you need to understand the concept in this case. So upthrust is equal to weight of fluid displaced. So the answer for this question is A. Question 15 says an airport has a mechanical system for moving luggage. The system uses a horizontal conveyor belt, a sloping conveyor belt, a lift, and a frictionless slide. A suitcase is moved around the airport using this system. The resistive forces opposing the motion of the suitcase are negligible. For which movement of the suitcase is the net work done on the suitcase greatest? So if you look at given options, for option A, it is given to us moving the suitcase a distance of 8 meters at a constant speed up the sloping conveyor belt here. So in this case, as this one is gaining potential energy, so we can say GPE, as this is gaining potential energy, so the system is gaining potential energy, it means there is net work done on the system. So net work done on the system in this case will be positive, so we can say this is positive. But we have to compare this net work done with this net work done. As in this case, object is gaining potential energy, and gaining potential energy here is much greater than gaining potential energy here. So A cannot be the answer. So A cannot be the possible answer. If you look at option B, it is given to us moving the suitcase a distance of 16 meters at constant speed along the horizontal conveyor belt. So in this case, object is moving at constant speed. Object is not gaining energy, means not gaining potential energy, not gaining kinetic energy. So it means that in this case, net work done on the system, this one is equal to 0 for the second, this part. If you look at option C, it is given to us moving the suitcase a distance of 10 meters at a constant speed vertically upwards on the lift. So in this case, object is gaining potential energy, and gain of potential energy in this case as compared with this one is much greater. So in this case, more work is done on the system. But if you look at option D, in this case, object is losing potential energy. So GPE is decreasing. It means work is done by the object. So we can say in this case, work is done by object. So work is done by object, or we can say work is done by system. So when object lose potential energy, work is done by system. When the object gain potential energy, work is done on system. And in this case, here work is done on system. So here we can also say this GPE is also positive. As here more gain in potential energy, so more work is done on the object. And in this case, there is less gain in potential energy, so less work is done on the object. So the answer for this question has to be C, because we need to find out in which case net work done on the suitcase is the greatest. So the answer for this one is C. D is not answer because moving the suitcase a distance of 12 meters at increasing speed downwards on the slide. So in this case object is losing GPE, so it means work is done by a system, but we need to find out work done on the system. So the answer for this question is C. A little bit tricky one, but you need to understand work done on system. Work done on system increases potential energy. So we can say this increases potential energy, and work done by system decreases potential energy. Question 16 says a car moves along a horizontal road with a constant velocity v against a resistive force capital F. The engine of the car has an efficiency of 25%. What is the input power to the engine? So simply, first of all, we can imagine we have engine, so this one is the engine. P in to the engine means the P input, we can say this is P in, and P out means the output power. This one has to be equal to F times V. So the percentage efficiency, we can simply write down percentage efficiency will be equal to P out divided by P in multiplied by 100. Percentage efficiency, we have percentage efficiency that is 25. P out we have, this is FV, and divided by P in multiplied by 100. For this question we need to calculate P in means the input power, so this will be equal to FV multiplied by 100 divided by 25. So if we solve this one we will get 4.0 F times V. So this is the input power to the engine. So the answer for this question has to be C. Pretty straightforward question. Question 17 says an object of mass 0.40 kg is projected into the air and follows a curved path above horizontal ground. The object takes a time of 1.5 seconds to move along its path. The object lands a horizontal distance of 18 meters from its initial position. Air resistance is negligible. What is the kinetic energy of the object at its maximum height? So this is just a simple projectile motion. So in this case we have projected object from here. So this is how object is projected. We can resolve this motion into two components. So it has vertical component and it has horizontal component. Horizontal component we can say this is ux, vertical component we can say this is uy, and the initial speed of this one is u. For this question we need to calculate kinetic energy at this point. So at the maximum height object has only horizontal component of velocity, mean this is only ux. As there is no air resistance, so it means along horizontal there is no force acting along horizontal, so the horizontal component of velocity will remain constant. And in this case we have the horizontal displacement, so we can say the horizontal displacement simply will be equal to the horizontal velocity component, horizontal component of velocity times time taken. So we have horizontal displacement that is equal to 18, ux we can calculate from here, and the time taken is 1.5. So we can say ux in this case will be equal to 18 divided by 1.5. But for this question we need to calculate kinetic energy at this point. So we can say kinetic energy will be equal to 1/2 mux square. So we have 1/2 and the mass of object is 0.40 and the speed we have that is 18 divided by 1.5 square. So if we simplify this one we will get 29 joules up to 2 SF. So the answer for this question is D. So simply we need to understand at the peak, at maximum height, object has only horizontal velocity, no vertical velocity. A little bit tricky question, but great question to test your conceptual understanding of projectile motion. Question 18 says a metal wire has length 5.2 meters and diameter 1.0 millimeter. The metal has Young's modulus 360 gigapascals. The wire is fixed at one end and a force is applied to the other end. The force extends the wire by 7.2 millimeters. The wire obeys Hooke's law. What is the force applied to the wire? So first of all, let's try to sketch. For this question, it is given to us that one wire is attached to one fixed end. So this is the fixed end. On the other end, a force is applied. So this is the force F, this is applied. We need to find out what is value of this force. So this question is simply about Young's modulus. So we can say Young's modulus, this one is equal to stress over strain. So simply we can write on Young's modulus, this is equal to stress over strain, mean the ratio between stress and strain. And stress is F over A, force divided by area. And here we have, this is delta L divided by L. So if we rearrange this one, we can simply write on, we will have FL divided by delta L times A. And here we have Young's modulus. For this question, we need to calculate F. So we can simply write down F will be equal to Y times A times delta L divided by L. Now simply we need to plug in values. Young's modulus we have, that is equal to 360 giga. Giga means 10 to 9. So this prefix you need to remember. Cross-sectional area. We have diameter, so we can write down cross-sectional area will be equal to pi by 4 d square. And d is given to us, that is 1.0 millimeters. So we have to convert this one into meters. Pi by 4 d square. So this is the diameter. So let me rewrite here. Cross-sectional area is equal to pi by 4 d square. And this is value of d. Delta L, in this case we have force extends the wire by 7.2 mm. So we have value of delta L. So this is 7.2 mm. So this is 10 to minus 3. And this whole is divided by L. L of this wire is given to us, that is 5.2 meters. So we can divide this one by 5.2, and if we solve this one, our answer should be equal to 3.9 times 10 to 2 Newton. So this much is the force applied on this wire. The typical question about Young's modulus, simply you need to understand Young's modulus formula. Young's modulus is the ratio between stress and strain, and then this form you need to understand. This form. Now simply after that you need to plug in values, you need to be careful with units, and you can find the final answer. So the answer for this question is B. Question 19 says the graph shows how the length of a spring varies with the force applied to it. The spring has unstretched length L0. When a force capital F is applied, the spring has length L1. What is the work done in stretching the spring to length L1? So in this case we need to understand work done on spring will increase the EPE of the spring. So we can say work done on spring, this is equal to the change in EPE of the spring. Change in EPE of the spring. And work done in this case will be equal to the average force applied on the spring times the change in length. So the average force, so we have maximum value of force and we have the minimum value of force. So the average will be F maximum plus F minimum divided by 2, because this is changing linearly. So we can say F plus 0 divided by 2. And delta L in this case is L1 minus L0. Now we just need to simplify. So if we simplify this one, we will get this is 1 by 2. We have capital F, and here we have L1 minus L0. So the work done on spring in this case is B. So B is our final answer. So this is how you can also calculate the change in EPE. This is simply equal to this area of triangle. That's all for today's video. I hope this video was helpful. If this video was helpful, please like and subscribe because your encouragement is very important. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. And if you need extra help, please join Patreon, and the link for the Patreon you can find in the description of this video.